We are all about solving absolute value inequalities today. We're jumping right in. Step 1, step 2, step 3, step 4. You're going to write them down in your listening notebook, and it's going to give you the 4 steps that you can use every single time to solve absolute value inequalities. Step 1, isolate the absolute value. Absolute, if I can spell it. There we go. Isolate the absolute value. So this is our absolute value. This little guy right there is the part of the inequality that has to be by itself. So in order to do that, we have one step. We are going to add 2 to both sides. And that completes step 1. Again, try to line up your inequality signs, work down the page. Step 2 will be to set up both cases. Just like we did when we were solving absolute value equations, we're going to be setting up 2 cases. Now, think about what we learned in the last video. This is an absolute value of x is less than or equal to 5. So before we do anything else, can we just anticipate what some of our answers are going to be? One of our answers will obviously be 4. The absolute value of 4 is less than 5. Another one, 2. Another one, 1. And think about what's happening here. What we talked about earlier is that when an absolute value gets smaller, then we're going to get closer to 0. So think about that as we set up our 2 cases here. And when we set up both cases, we are going to lose the absolute value bars. We don't need them anymore when we set up these 2 cases. It's coming out now. So x is less than or equal to positive 5. This is the positive case. Notice that the inequality sign stays exactly the same for the positive case, but the negative case, x will be greater than or equal to negative 5. This is the negative case. And when we look at the negative case, we do flip the sign. Flip, okay? So write yourself a note so you can keep up with these details. So that's step 2. Set up both cases and lose the absolute value bars. Step 3 is to solve, which this is a very simple one, so it's actually already solved for us. Step 3 is done. So think about what we've got here. Also keep in mind, this, once we get that absolute value by itself, we look at it. Is it less than or is it greater than? This is a less than. Less than. This becomes an and situation. So if we now go on to step 4, which is to graph on the number line, knowing that this is an and situation, and when we have an and situation, we're going to have a conjunction of sets. Conjunction. That means our sets are going to meet in the middle when we have an and situation. So what numbers? Our answers are less than or equal to 5 and greater than or equal to negative 5. This is an and situation. So I'll put negative 5 there, positive 5 there, zeros in the middle. Remember, we read from left to right. Our numbers should be increasing from left to right. Also consider both of these are or equal to, so we will have a solid circle on the negative 5, a solid circle on the positive 5. And remember what we said? What were some of our answers? Yes, 4 is an answer, 1 was an answer. How about negative 3? Is it an answer? Is the absolute value of negative 3, which is 3, less than or equal to 5? Yes! So, and situation, that's a conjunction of 2 sets, and this is what our number line looks like. So, step 1, isolate the absolute value. Step 2, set up both cases and lose the absolute value bars. Step 3, solve each of the inequalities. Step 4, graph on the number line. We're going to do it all again now. So here goes. Step 1, isolate the absolute value bars. Isolate the absolute value bars. So in order to do that, look at what is given. This is -3 times the absolute value of x minus 6. The inverse operation of times -3 is division by -3. And that is the glitch. And when we have the glitch, remember that we will be reversing or flipping that inequality sign. So the -3's cancel, and please remember to use a fraction bar to show your division. So this allows us to isolate our absolute value bars. Greater than was less than, flipping to greater than because of the glitch. And we divide by negative. -9 divided by -3 is 3. So there's step 1. Step 2, set up two cases, lose absolute value bars. Okay, so here are two cases. Remember, positive case, negative case. When we set up our two cases, we're losing the absolute value bars. So x minus 6 is greater than +3. Remember, the positive case stays exactly the same. Next, x minus 6 is less than -3. When we do the negative case, the sign flips and the sign of the number flips. This is the positive case, this is the negative case. Step 3, and we actually got to do it this time. Solve the inequalities. So we're going to solve the inequalities here. We have two of them. So x minus 6 is greater than 3. We're going to add 6 to both sides. X is greater than 9. X minus 6 is less than -3. Add 6 to both sides. And -3 plus 6 is 3. Now think about what we've got here. This is a greater. This is an or situation. Also think about, when does absolute value get bigger? Absolute value, by definition, is the distance from 0 on the number line. So where does absolute value get bigger? When you go farther away from 0 on the number line. So we are going to get a disjunction of sets. This is an or situation, so the trains are going in opposite directions. Here's 3, here's 9. Be certain that you get your numbers in correct order from left to right on the number line. Put 6 in the middle, 0 down here, 12 over here. We've got both signs are strictly greater than, strictly less than. This is an open circle on the 3, open circle on the 9. Our answers are bigger than 9 or less than 3. So that is to the left of 3, that is to the right of 9. Solving absolute value inequalities. Isolate the absolute value, set up the two cases, step 3, solve, and then of course step 4, we just did it, graph it on the number line. Let's do it again. Step 1, isolate. Isolate the absolute value. That's what we're doing for step 1. This time it's going to take 2 steps because there are 2 things that have been done. We need to go in a reverse order of operations. So the first thing we will undo is the -7. So we will add a +7. 7 to both sides because negative 7 and positive 7 are inverses. So now we have 2 times the absolute value of x minus 6 is greater than 4. Next, undo times 2. The inverse operation of multiplication is division. Show division with a big fat fraction bar. 2's cancel. The absolute value of x minus 6 is greater than 2. Finally, there's step 1. Step 2, set up 2 cases. Lose the absolute value bars. Here's the positive case, and here's the negative case. Once again, focus on what's changing. The positive case is greater than 2. It does not change. But the negative case flips the sign and changes the sign on the number. Both of the signs change. It's kind of like the opposite of is what's happening here. So, step 3, solve. Solve the inequalities. Plus 6 plus 6. X is greater than 8. Plus 6 plus 6. X is less than negative 2 plus 6 is 4. So, this is an OR situation because it was greater, if you want to put a play on the word greater and less than. This is an OR situation. The graph, which is the 4th step, will be a disjunction of sets. The graph will be a disjunction with the 2 sets going in opposite directions. Here's 4, here's 8, we'll put 6 in the middle, 2 over here, 10 over here, strictly greater than, strictly less than, open circle, shade to the left, open circle, shade to the right. Last problem. Again, step 1, not going to write the steps this time. Step 1, isolate the absolute value. In order to do that, there's only one thing that's been done. It's been multiplied by 1/2. To undo multiplication by 1/2, we could divide 1/2 by 1/2, but remember, division by a fraction is the same as multiplication by the reciprocal. So let's just save ourselves some time and let's multiply both sides by 2. When we multiply 2 over 1 times 1 over 2, the 2's cancel and we're left with 1. Why? Because they're reciprocals. So there's our step 1. We have isolated the absolute value bars. Now we're going to go to our 2 cases. So negative 2x plus 5 is less than or equal to 4. Less than negative 2x plus 5 is greater than or equal to negative 4. This is the positive case. It stays exactly the same. This is the negative case. You flip the sign and change the sign on the number. So this is step 2, setting up 2 cases. Step 3 is to solve. Minus 5, minus 5. Negative 2x is less than or equal to negative 1. Minus 5, minus 5, negative 2x is greater than or equal to negative 9. Now, I did them both to the same point just as a reminder that we are about to divide by a negative. That's the glitch. That's the glitch. So we're going to divide by negative 2. X is greater than or equal to positive 1/2 on the other side. Divide by negative 2. Divide by negative 2. X is less than or equal to 9/2. And because these are halves, these are very easy to change to a decimal. Normally we don't do much changing to a decimal, But in terms of the number line, if it helps you understand what is where on the number line, then go for it. 1/2 is 0.5. 9 halves, 2 goes into 9, 4 times, and 1 left over, so that is 4.5. So here's what we've got. A less than situation originally. Our answers are greater than 0.5 and less than 4.5. So this is still going to be a conjunction. I'll put my number line right over here since I have plenty of room. 0.5 here, 4.5 here. If you want to, we can put 3 right in the middle. We can put 0 over here and 5 over here. That'll work. Remember, the number line doesn't have to be perfect. You just want it to symbolically represent your solutions. So, numbers that are bigger than or equal to, so because of the or equal to, it's going to be solid. And so bigger than 0.5 and then less than or equal to, solid again, 4.5, everything in the middle there. That's a conjunction of sets. Why do we have a conjunction? Because this is an and situation. There you go. That is solving absolute value inequalities.